electronics and communication systems. So with this introduction, sir, once again, welcome for this expert session, and I will hand over the mic to sir. Thank you.
Yeah, thank you, madam. Good morning, the faculty members, the participants, outside participants, and participants from SPIT. Today it's a remarkable day. Being a electronics and telecommunication student, not only electronics and telecommunication, being a science student, being a technology student, should note it this day, that is 13th March 2024, a to remember. Being a young generation, you have another 50 years of your professional life, and you should know that a great thing is happening today. Foundation Day, 3 facilities. I mean, it's a beginning. I know just a beginning. It's a semiconductor industry is not just a factory. It's a town. It's a state. It's a huge setup. It's as good as entire Maharashtra is being reconstructed. It's as good as that. It's a why billion, trillion-dollar industry. Entire world, if you see entire world, how many countries are having trillion-dollar economy? Only semiconductor has the potential. So imagine what is a semiconductor industry. So I should not say much about it because that session is there by Prime Minister, Honorable Prime Minister of India. I will just touch some basics, being a telecommunication student, and specifically I have mentioned some few topics that is about project, product, and research. Since a lot of bad practices are happening, so we are unable to differentiate between project, products, and research. And you need to understand the scope and the opportunities. So that's my last portion. After that, exactly at 10:30, I will stop my session and will broadcast the live telecast of the Prime Minister of India, who is inaugurating these 3 facilities. So what you can see is that these 3 facilities are collaboratively happening. That means you can see TEPL and some Taiwan-based companies, some Korean-based companies, or some Israel-based companies, some companies are collaboratively investing in India to begin with 3 places, 2 in Gujarat, 1 in Assam. So what does it mean? It's not that only foreign people are investing, or it's not that only Indians are investing. It's a joint venture. Why it is so important that 2 partners has to be there in this venture? If you should note that semiconductor industry is not new, right? However, in India, first semiconductor industry started in 1980s, and in Punjab, Mohali, where Semiconductor Complex Limited, SCL, popularly known as, is a investment by Government of India. It's a public sector company. But I would say it's a failure model, right? It was never popular, this SCL. There was no popular products in the market. Unfortunately, even today, if you want to buy a BC547 555 IC, they're all manufactured by National Instruments or some other companies. That means even a transistor is also not manufactured in India. Forget about integrated circuits. Even 1970s transistor also we are not manufacturing. Though I will take the questions after the end of the session. The live is happening. Okay, so there are companies, BEL, public sector companies are also there. They do manufactures, but then when it comes to comparison, in India, some transistors are manufactured. Now you buy a transistor which is manufactured by our companies, and if you buy a transistor manufactured by multinational companies, look at the performance, look at the reliability, look at the cost. Then what industry feels is that even by on nationalism also, if I buy my own component, my product will miserably fail because I cannot compete in an international market. Are you buying a HMT watch today? Anybody is buying? It's an Indian company. Why nobody is buying a HMT watch? Ambassador car is an Indian company, right? Public sector company. Does anybody is buying Ambassador car? So though doors are open, now it's not a protected environment. It's an open environment. Anybody can buy any product anywhere in the world. Any company can come to any country and they can sell their products. So now you cannot go by in country sentiments, right? So naturally happens in the market also. Though we have some companies who are into semiconductor, but then when it comes to quality, cost, reliability and all, we are unable to compete. So what is important is that in semiconductor, particularly in semiconductor, why semiconductor? In even four-wheeler ambassador call also obsolete because every year the models are changing. So they are unable to compete with Japanese and those Korean companies. If that is the case in mechanical and civil engineering, can you imagine what happens in semiconductor industry? That's what is my presentation is all about it, right? Forget about year. Even every day it is getting obsolete. Every day a research is happening, inventions are happening, and the industry which you have established is getting obsolete. That means the machines which you have purchased, the manufacturing plant you have set up is getting obsolete. That is the reason in the entire world, only few companies, you can count it on fingers. You can count it on fingers how many companies are manufacturing semiconductor devices and how many countries are having that ability to set up those companies. Even if you invite those semiconductor companies, they doesn't come to your country. Please remember that. It's not a software company where if you provide a nice air conditioned building infrastructure, any company will come and start doing the business. Absolutely no. In a semiconductor industry, if you want to invite a company, first of all, you have to provide such a infrastructure. It is as good as building a new state in terms of even a power requirement. I would say as good as the Mumbai, whatever the Mumbai's power consumption, that much power consumption you have to provide to one semiconductor industry. Means megawatt and gigawatt of power you have to provide to a semiconductor industry. And not just a power, please understand. And power, people doesn't understand. It's not about power. It is about the quality of the power. Today we are talking about power is there, power is not there. We talk about only two things. In Mumbai, power is there. The moment if you cross Thane, power is not there. Power cuts are there. I am saying, I'm not talking about that. I am saying power is there, but does it have the quality power? That means the power which you are supposed to source, even if it has a small fluctuations, the frequency instead of amplitude or phase, if any small fluctuations will destroy the entire process of the semiconductor manufacturing facility. I'm not talking about reliability. I'm talking about the quality of the power. So that kind of guarantee, unless you give, unless means who will give? Government. Unless government provides that kind of a guarantee that we provide power, we provide the quality power, and particularly the policies. Why this SCL company miserably failed? Because the quickly you have to take the decisions. I want to buy this machine. I want to upgrade. I want to employ. I want to import. Whatever. You have to quickly do the things. That doesn't happen in public sector company. That's the reason that model failed. So today, I mean, government of India actually it's not investing. It is looking for partners. It is investing undoubtedly, right? Nobody will come if you don't invest. But then on a equal partnership basis, right? So that's why we are not giving 100% to outsiders. Then it will be a blackmail once again. They will start dictating about your country's policies. But so 50, I believe it's a some 50% partnership. That's how this model is. Why it took almost 1980s. That means how many years it took? Almost 50 years again to start the semiconductor industry in India. It's, I would say, it's a remarkable day. And being a young engineer, you have a potential, a great potential in coming years in electronics and telecommunication manufacturing facilities in this country. So some of the points I will touch, but I am not a VLSI faculty member. I'm just only highlighting some things. Otherwise, we have Dr. Reena is there, Professor Bhagat is there. Some professors are there who are the doctorates in VLSI. Probably, if you are interested in microelectronics part, maybe you can talk to them. Or I was just, I would say, motivated in this field because when I was doing PhD at IIT Bombay in this country is the only IIT which has the facility of fabrication. In the entire country, only one IIT, Bombay, has the microelectronics lab where if you wish, you can manufacture a IC. Only one IT. Not even industry, I told you in what shape. But in academics, only IIT Bombay has. IIC Bangalore has. They are jointly sharing the some resources. So if at all, if you are interested in your research in microelectronics, semiconductor industry, through your institute, you can. It's open. It's an open mission. You can apply to IITs, IIC Bangalore, IIT Bombay. They allow you with proper permission to make use of that facility. So can you imagine? That means out of 30 IITs of India, only one IIT has that facility. So what is the amount of budget involved? How many hundreds of crores you have to invest for one laboratory? And it gets obsolete. That's the problem. No, if you, it's not that if you invest at least one generation, you can use it. No, absolutely no. That's what I'm going to touch some of the points. All right. So why this demand is, I hope being a computer science and electronics student, you can understand it is all about computerization of the objects, right? You have seen everywhere there is a software and hardware. Everywhere there is a semiconductor device, right? Even you have seen that some of the companies, they are implanting the chips in the brain, right? That is the futuristic way of doing the things. But otherwise, automation is everywhere that we have seen. But it's not just a automation. Today we are talking about artificial intelligence inside the device. It's not, I'm not talking about the workstations and the cloud platforms. I am saying a device has the ability of a knowledge, right? You need to fabricate the knowledge in the device. We also have some PhD research scholars, Payal Shah, where she's talking about the behavior of a brain cell. Can we model it and put it inside a IC? So we have a great PhD scholars in this campus itself. If at all, if you are interested in the career, do approach them and they are the right people to advise you. Okay, so like I said, being a physics student, the moment in 12th standard, probably you might have come across what is conductors and what is insulators, and semiconductor is in between. It's not either conductor or insulator, it is in between, semiconductor. So what does it mean? It means you take some material, initially it is an insulator, and you make it semiconductor. Okay. Now you need to find out which of the materials which are insulator, but they have the ability to become conductors, semiconductors. Abundant everywhere available is silicon, right? Everywhere silicon is available. Otherwise, no, germanium, gallium, and other materials are also used in this industry. So we know that right from a simple automation to today, we are talking about these robots, mobile phones, right? All these products which are manufactured by these semiconductor devices. Surprisingly, what you can see is that 70% of the semiconductor industry is controlled by only two companies. Only two companies are controlling 70% of the entire world supply. One is Taiwan based, other is Korean based. Okay, now all of a sudden, why the entire world is looking at India? Why it took 50 years to come to India? Why all of a sudden? Probably you know the reason. After COVID, what has happened in who are the people who manufactured the COVID virus? The entire world has gone against them. Now they want a no a reliable country, democratic country. So that's the reason why they're looking at us. That's the one reason. Second reason is that now entire world is divided into groups. They are in groups now, right? Now no more we believe the whole world is one family, particularly Bharati Vidya Bhavans believes that. But however, if you even in G20 also we propagated the same thing, the whole world is one family. However, if you look at the reality is that the groups, so everybody belongs to one group, so one group doesn't like other group, so they doesn't import, the supply chain is disturbed, they are not supplying. Earlier the entire global manufacturing is happening at one or two places, but however not no more. It's a rivalry is happening, wars are happening, so they doesn't want these facilities to happen in their enemy countries. That's the reason being we are a friendly country to the entire world. Now the whole world is looking at India. That's the reason why it's not that हमारे ऊपर उन लोग को ज्यादा प्यार है, ऐसा कुछ नहीं है. It's just they are helpless. And please remember, we have the young potential, young students, young generation, and highly qualified people. I don't say skilled, but qualified people are there in this country. That's the reason the whole world is looking at our country. We have one drawback. That's the reason why people didn't come to India. That is, we are over democratic. We had more than required democracy. That's the problem. The semiconductor industry is not coming. Like I already said, what happens once you invest in a huge infrastructure, then tomorrow you cannot say you band karo, no, you remove this, no, or there is a strike, worker strike, this and that. You cannot do like that. It's a huge investment. It's $1 billion investment. So it's not a joke, right? If such a companies, if they want to invest, then you have to give the guarantee. I already told you about the power guarantee. What kind of power agreements you have to give? If you don't uh, uh, provide that, do you know what are the kind of penalty will be there? You will be bankrupted. That kind of penalty will be there. So you have to give such a kind of guarantees when they invest in this industry. Yeah. So first year physics, if you remember, what happens in these processes, like I said, even if you look at a company like iPhone, right, Apple, BMW, or Boeing 707, whatever these Boeing companies, please understand one thing: no company manufactures every part. Rather, I would say 95% of the parts are not manufactured by them, including, I am telling you, this BMW. The Mac company doesn't manufacture phones. You know that. It doesn't They outsource the things, including four-wheelers. There may be 5,000 parts in a four-wheeler. None of the parts are manufactured by BMW. So tomorrow, don't believe that if BMW has started a factory in your state, it doesn't mean that all parts are manufactured in that factory. Absolutely no. Majorly, 95% are assembled, maybe one or two parts may be manufactured here. Same thing happens in semiconductor industry. Don't think that today the facility is started in India doesn't mean that every single step. I mentioned 6 stages of manufacturing. Don't think that everything happens at one place or in this country. No, absolutely no. So you will be surprised to know that the first stage. What is the first stage? First stage is a raw material, right? Silicon is a raw material which is in solid state. You have to melt it and you have to bring it to a liquid state first of all. Then you have to cut it as a wafers. You have to polish it. Then that is called a silicon wafer. Do you know how many countries or how many companies are there who are making silicon wafers in this entire world? One or two countries or one or two companies. You may be buying pen drives, mobile phones, or laptops from 100 companies. Please remember, none of them are manufacturing their own silicon chips. Do you understand? So, the entire world, only one or two companies are supplying the silicon wafer also. I'm not talking about the IC manufacturing companies. IC manufacturing company requires a wafer. Today you have a PV panels. In India, 5 to 6 companies are manufacturing PV panels. Please remember, even if you visit the PV manufacturing facility, PV in the PV panels, that wafer, right? That wafer is not manufactured. It is only assembled here. So PV companies, right, volatile cells company doesn't mean that cell is manufactured here. Cell is imported and assembled here. Means only joining the wires and making that module and so on. So is the case here. Please remember, don't think that entire ecosystem is possible at one place. Actually, rather they don't do that. There is a great danger if everything is manufactured at one place. For example, look at ISRO. ISRO is no, they are manufacturing their own satellites. Their launching pad is at one place. In this country, at 7 to 8 places, that rocket is parts are manufactured and finally assembled at Sriharikota and launched from there. Launching pod is at Sriharikota. But don't think that so since it is launched from Sriharikota, that entire thing is manufactured there. Absolutely no. It is from different parts of the country assembled at one place. And you are surprised to know that why can't you do that there only? No, it's very easy to transport. They don't do that. Why? There is a great danger involved in developing in any facility at one place. Because whenever there is a possibility of flood, earthquake, tsunami, or wars, during the war time, they hit the most important key places. So they never ever, whenever there is a war, first they attack Mumbai. Please remember, there will be a siren in Mumbai because they know Mumbai is the financial capital of this country. So first they will try to attack such kind of key positions. So similarly is this industry where even if it is ecosystem is required, but it won't be at one places. They are at different places of the either the country or the entire world. So that's the point you need to remember. Even if there is some facilities being inaugurated, it may be a facility, a part of the facility in the entire system. Okay. After that, what happens is once you make the slices, which is done by some of the world-class companies, and then it goes to, like for example, in PCB manufacturing, particularly if you remember how a PCB is manufactured. You design the PCB, layout you design, but then finally you want to get it done a PCB. But then the layout is in the computer. How will you transfer your layout on a PCB? So there is a process called you take a photograph of it, positive, negatives, and then you coat your PCB with a photosensitive layer. You keep the films in a dark room. You expose through a UV light. The entire layout is transferred on the PCB. Then you put the PCB in a ferric chloride, some etching machines. The copper will be etched out. Tracks will be there, and then there will be a green layer coating will takes place, screen printing and all. More or less the same thing happens in semiconductor industry. Okay, because when you have a silicon wafer, what is that? It is an insulator. It's not even a conductor. It's a pure silicon, which is it's an insulator. How to make it a semiconductor? You have to add N type of material or P type of material. That is called doping. Okay, and then selectively doping. It's not that entire substrate you want to make it P type or you want to make junctions. For example, if you want to make a diode, there will be a P junction, there is N junction. If you have an NP and then NPN, you have to dope it. So there will be selectively you have to do that. That's a problem. Second is that you do not want to expose the entire this thing because you are not making one component. In one silicon wafer, you are making hundreds and thousands of ICs or transistors. That means it's not that one wafer is completely exposed to the UV light. No, selectively you have to expose. So that's the reason where this photolithography process is involved here. Doping process will be involved here, and deposition, thin layer of films will be deposited on the substrates, and finally etching takes place. Etching take place means, like I said, how we eat away the copper, extra copper. Similarly, we have to eat away the extra silicon, unwanted silicon. Then the components are fabricated, but that's the before that there is one more stage. You want to finally make a IC where you don't see any silicon here. What you see is something ceramic, plastic, some metal, something will be there. But inside this, right, there is a silicon wafer which you cannot see, and it is provided with some pins, some aluminum pins. But if you are using this IC for some military, they may be gold plated pins or something like that. So that is called finally packaging. So these many processes are involved if you want to make a right from a transistor to an integrated circuit. You understand? Okay, now these facilities are there in IIT Bombay also. They are there in Punjab also, Mohali also, right? Then why we are unable to manufacture for our own needs? Forget about the export. Why are unable to do it? The reason is, okay, let us look at today where we are. We started with small scale integration. I'm sure you might have studied in first year also that the number of transistors to be fabricated in a IC may be in tons, maybe few tons you have to fabricate. For example, you know gates, right? NAND gate, NOR gate, you have seen. A gate, for example, NOT gate. What is NOT gate? NOT gate is nothing but one transistor. Transistor can be a NOT gate. So if you integrate a transistor in a IC, you made a NOT gate. So such type of transistors are in tens. If you are integrate in one single silicon wafer, we call this small scale integration. So that has gone to medium scale, large scale, very large scale, ultra large scale, and now it is in what is the scale? Billions. Means in such a silicon, means what is the size of the silicon? It is still in less than a inch. In a less than a inch, where the number of transistors you are fabricating is not millions, it is billions, and it is very soon is going to touch the trillions. Do you understand? IC size is not increased. IC size is still same. Last 50 years, IC size is still same. However, you started with 10 transistors. Today you are fabricating billions, and very soon it is a trillion transistors. What does it mean? It means the size of the transistor day by day shrinking. Do you understand? Do you understand in 1 inch wafer, 1 trillion transistors are there? So what is the kind of technology required? What is the kind of laboratories required? What is the kind of machinery are required? You cannot use the same machines. Okay. Moore's law. He is a founder member of Fairchild and Intel. He's a scientist. He is the fellow who started, is the CEO of Intel, 1965. In 1965 itself, he has predicted that every 18 months to 2 years, the amount of integration, what we are doing, will be doubled. Now see, almost 60 plus years are over. The law is still proved, right? The amount of integration is still doubled every time. If you are unable to do that, then you have to close your factory. As simple as that. You're obsolete. Nobody will look at your component. That is the challenge, where it's not that, right, you manufacture something, you keep on selling something. It's not possible, particularly in this industry, because the amount of obsolete is so fast. Look at the right side. What is the size of a transistor? The size of the transistor in 1968 is 20 micrometers. Means the amount of distance you have to maintain between one transistor to other transistor is 20 micrometers. The micrometers has gone in 1980s. Now today in 2024, we are talking about the distance between the two transistors is 2 nanometers. You understand what is nano? How much is nano? Minus 9. 10 to the power of minus 9. So what is the size of your hair? आपका बाल जो है उसका डायमीटर कितना है मालूम है आपको? How many times? ये जो हवा में जो डस्ट पार्टिकल है आप जो देख नहीं सकते हो उसका डायमीटर कितना है आपको मालूम है? So 10 to the power of 9 क्या होता है? Just try to compare. So that's what you need to understand, that a nanometer means a average human hair is 60,000 times than a nanometer thickness. That's the kind of scaling happens inside a IC. So what does it mean? It means when this manufacturing is happening, you are not even supposed to enter. हम लोग when we go to mess, वो लोग कैप क्यों पहनते हैं? आपको बाल गिरना नहीं चाहिए खाने में ना, इसलिए कैप पहनते हैं ना. तो कैन यू अंडरस्टैंड? कैप तो दूर की बात है, यहाँ तो डस्ट पार्टिकल जो हवा में जो पार्टिकल्स पर इंच बोलते हैं ना, द पार्टिकल्स वट एवर वी आर टॉकिंग इस 10 टू द पावर ऑफ माइनस 9 पे है, जो आप देख भी नहीं सकते हो. आपको माइक्रोस्कोप, आई डोंट नो व्हाट एक्सटेंट you need to magnify if you want to see those dust particles. That kind of environment you have to provide if you want to manufacture such kind of integrated circuits. Because see, finally you are doping, you are depositing the impurities. You have a pure material, you are depositing impurities, but हवा में इतने सारे impurities है, आपको पूरा process को damage करेगा. So what kind of environment you have to provide? Just imagine. So that is what you need to understand, the scaling of a this manufacturing facility. All right. So being a computer science and circuit branches, you also need to understand it's not just today we are talking about one CPU. Today we talk about dual core, quad core, hexa core, octa core, deca core, multi core. That means now the expectations from the industry is not just a integrated circuits, a CPU within CPU, a CPU within CPU. Such kind of CPUs is gone up to octa, deca is the kind of integration. Earlier, what is happening? We used to say multi-processor. Means you can have multiple CPUs, multiple ICs. But today, the industry doesn't want multiple ICs. They want within one IC multiple CPUs, multi-core, 10 cores. That's the kind of demand. So can you duplicate the same core 10 times, 20 times is what is the demand. So that's the kind of computational power people are looking for. Now, when it comes to packages, you can understand that in first year when you have done the digital electronics practicals, you have used this IC called dual inline package, DIP package, where pins are there left side and right side. There you haven't seen the pins on bottom side and top side. You have not seen the pins where pins are not there, only dots are there. But however, now you see this IC where there is no the pin holes. They are SMD packages, surface mounted devices. So broadly, if you want to classify these IC packages, you can classify as a surface mounted versus inserting mounting. Now here there is a great challenge here. The last column, if you see ball grid array, BGA package. BGA package means here even pins won't be there. Only dots will be there. And where will be the dots? Below the IC. Right? What is the distance between the dots? Less than a mm. So if you have a less than a mm dot, first of all, how do you fabricate? Even if it is fabricated, how do you mount it? That means even mounting itself, you require a robotics. You cannot do it by hand. You cannot do the soldering also. So that means even fabrication, manufacturing of the motherboards and daughter boards also a huge challenge if you want to use such kind of semiconductor devices. That's what I said. It's a complete ecosystem. It itself is a country. If at all, if you completely see all the stages of a semiconductor industry. Okay, so as we know, software, hardware is a choice. First of all, many of you are confused that no, what is software and what is hardware? Please remember, software means CPU. We see today it is a semiconductor day. That's why please remember software means CPU. Hardware, people are confused. Hardware doesn't mean that CPU. Please remember, hardware doesn't mean CPU. Hardware doesn't mean that what you see is hardware. Absolutely no. Hardware means hardwired. Okay, where there is no software, software is converted into hardware. It is also a computational device that is called system on chip. So you will find such kind of manufacturing facilities, particularly some of our rivalry countries are having, where they have the ability to manufacture a IC as per the customer's wish. That is called system on chip. Today, for example, if you want to make a guitar, today you want to make a toy, today you want to make a wireless device, they will make a IC for you. No software will be there. For example, calling bell. There is no software. Don't think that it is playing a song doesn't mean that software is there. Absolutely no. There is no. It's not an iPod. There is no software. There is no CPU. It is hardwired. So please understand when I'm saying here, that means that even in the semiconductor industry also, people manufacture CPUs, but people manufactures without software, hardwired. That means there's a huge industry where they want customized ICs. What is general purpose ICs? Can you name few general purpose ICs? I3, I5, I7, your 8051, PEAK, ARM. These are all general purpose. General purpose means they are not manufactured for a specific application. You can use that CPU for different applications. However, for example, if you see a calling bell, if you open the calling bell, you don't find ARM or PIC or MSP or DSP. You will find one black spot, one dambar, ऐसा बिंदी एक रहेगा अंदर. उसको पिंस भी नहीं रहेगा, आपको देखने के लिए पिंस भी नहीं मिलेगा. That is called system on chip. If you open your calculator, open it, you don't find 8051 or PIC or ARM. एक dot रहेगा. So those are called system on chip. That means the ICs are manufactured as per the customer's requirement, application specific, not general purpose. I'm not going by comparison, but it itself is an interesting field. When do we go by software approach, means microcontrollers, microprocessors, and so on? When do we go by hardware, hardwired approach? Is a choice. All right, so like I was saying, general purpose means what you find is the functional blocks is a general purpose in nature. Application specific means it is a design for a specific application. For example, digital signal processor. What does it mean? It is an application specific. Means the CPU is designed for digital signal processing. Means in order to process a signal, what kind of functional blocks are required? What functional block is required? Can you name 3 functional blocks in a DSP? Hello? Name 3 functional blocks which are required at DSP, digital signal processing. ADC. Without ADC, DSP is possible. DAC. Is it possible? So converting analog signal into digital, converting digital signal into analog is 2 functional blocks. So digital signal processing means it should have a powerful analog to digital converter, digital to analog converter. Do you understand? So like that, some computational unit, powerful memory, and so on. So they are called application specific. But I am saying there is another industry in semiconductor manufacturing facility called single purpose. Single purpose means like calculator, like a toy, like a calling bell. All these things, you cannot use that for some other purpose. As per the application that IC is manufactured. You don't get in the market also. You don't know the architecture also, because that manufacturer has got it done. Earlier, we our professor used to be there, Dr. M. Shah. He was the first fellow in 1980s. We approached Singapore and got it done. This single purpose ICs those days itself. So customization. Somebody approaches me, we design the thing. For example, there is a SMPS. In SMPS, instead of using my regular regulators, all these things, I will design some IC, specific IC. So I will get it done, a special IC from so and so company. But it's a expensive option, because you are getting a manufacturing IC as per your wish. It's very expensive. However, if you have many customers, it is the cheapest solution. So it is all about the, I would say, the amount of business you are having. Quickly, we have another 15 minutes. Quickly about to know about that. It doesn't mean that semiconductor doesn't mean that you always need to have a huge factories, huge power stations, huge infrastructure. Absolutely no. We are already having such type of facilities in Pune, Bangalore, some extent Hyderabad and Madras, called VLSI design centers. So the initial stages, if you carefully look at the slide, where the processes which are involved in the design stages, that is still happening. Most of the CPUs of the world-class companies are designed in India. Please remember, in Bangalore, some of the facilities like Texas, those other companies, these Intel, AMD, they are having research facilities here, not the manufacturing facilities. Design centers. What do you mean by design center? Design center में आपको क्या चाहिए? एक लैपटॉप चाहिए बस. तो आप ये पेड़ का नीचे भी बैठ के डिजाइन कर सकते. So that facility we are already having. So the initial stages are already having are happening 30 plus years in this country. We have excellent design centers in this country. But however, I said it's not that easy, because we are talking about 10 to the power of 9 minus 9 size. That means the tools which you are using, not the conventional tools what we use in our day-to-day life. There has to be that kind of technology supported tools. Cadence or some other companies are uh, suppliers for those tools, whatever. So upgradation also has to happen at that level, even in the design stages. All right, so quickly, some national level significance. As you know, 2023 estimated is around $625 billion is the market potential, and within this 7 to 8 years, it is expected $1,300 billion. That means as good as $1.3 trillion economy only in global semiconductor market. That is the potential of this semiconductors. And if you see the areas also, you all know majorly where there is a potential. Particularly, you all know memory. Memory has a huge potential, because memory, when you buy a mobile phone, your 1/4 of the cost of the mobile phone is because of the memory, right? You ask few extra GB, he will charge you another 10,000 rupees. When you buy a laptop, you ask extra few GB, he will ask another 5,000 rupees. Memory has a huge potential. Not only, I mean, inside the computers, like pen drives you have seen, right? So wherever. Today, when we are talking about artificial intelligence, please understand, artificial intelligence without a database, there is no artificial intelligence. AI in a device means database has to be there. Database means memory. So the amount of memory today is integrated in a single silicon wafer is how much? Terabytes, not even gigabytes. So we reached a stage where a single silicon wafer has the ability to integrate terabytes of memory. That's the reason why today we are talking about AI enabled devices. It's possible. And what is the cost of it? In 10,000 rupees also you have a smart devices. The amount of brain a child is having is already having a chip. Terabytes. Child के अंदर तो terabytes का database तो नहीं है ना. But we can integrate that much in a IC. That is the kind of demand, particularly in computational devices and the memory devices. And the industry, right? You all know, particularly telecom industry, right? Richest companies in the world, richest countries in the world, who are they? The people who are manufacturing the mobile phones. That's the kind of demand. घर पे कंप्यूटर नहीं है, घर पे टॉयलेट्स नहीं है, लेकिन घर पे मोबाइल फोन्स. That is the kind of, I mean, every घर पे चार चार पांच पांच मोबाइल फोन्स है. Prime Minister of India keep on saying, एक शौचालय तो बनाओ भाई. If like that, the Prime Minister has to request. However, mobile phone तो पूछने का जरूरत नहीं. अब लोग keep on upgrading. हर 6 महीने में नया मोबाइल फोन. That is the problem. So we are not bothered about our health and all these things. However, attractive things. Research happens where there is a demand. Invention happens where there is a demand. So जहाँ demand है वहाँ supply है. So naturally जहाँ mobile पे इतना demand है उतना बाकी areas में नहीं. Particularly health में तो nobody cares. Anyhow, so that is the more than 40% of the global semiconductor things are happening in telecommunication. Please understand that's the kind of, and we are fortunate that you are in this branch. You are fortunate. You are lucky because other people have become fools. Okay, so India, particularly the investments, majorly north, some east, some west, some part is in south. Hopefully, it may increase. And as I already said, in India also we have a larger scale in electronics and telecommunications, some extent in automation and data processing. That is a kind of this thing. So you can see the top major players in semiconductor industry. Though we have 15 plus companies are there, but major players are Taiwan based and the Korean based companies. Only Samsung and the Taiwan based semiconductors are the leading companies. However, you are surprised to know that Nvidia is hugely investing. Even the Mac company are going to hugely investing in semiconductor industry because that is the kind of demand happening in artificial intelligence. Now, literally, president of the other countries has to dictate these countries do not supply your ICs to the XYZ countries because today the ICs are having brain intelligence. So if an intelligence based ICs, if these companies are manufacturing Nvidia and Tesla, all these things they're manufacturing, there is a possibility of misuse, military usage and anti-national things happens. That's the reason, I mean, even a president of a country has to intervene to tell the companies that don't sell these things and all. So look at the kind of potential and demand, which is where the very soon the brains are going to be manufactured in terms of ICs, which will be everywhere. That's the reason why this Nvidia. What is Nvidia? What is the product of Nvidia? What do they manufacture? Graphics, right? Graphics. But then, do you understand the difference between a CPU and a GPU? A CPU is having only one computational unit. However, a GPU is having millions of computational units. So that means the amount of demand for a graphics is much more than the demand for a CPU. CPU only takes care of the multitasking environment and executing the operating system. But however, today what we want is user friendly, like a human behavior and so on. That's the reason why these companies are coming forward for manufacturing their own ICs in this domain. Okay, so that's what I think. We do not have much time. Uh, Mobiles, wearable devices, IT, consumer sectors, automotive. These are projected things. So 44% is in industrial sector, and similarly, automotive is around 38% is projected in 22 by 2026. So what are the challenges in this semiconductor industry? As a student, you should remember that it's all about the, of course, industry is taking care of the infrastructure and supply chain, but what is required is a skilled power. That's the key point. Why people comes to country, our country, right? They can go to some other part of the world, but why they are coming here? Because of the skill. So unless you have the skill, right? Unless you have the ability to work in these centers, you are not a labor. Please understand, we are not a labor to work in these countries. We are supposed to be the designers, developers, to work up to that potential nanometer, 2 nanometer technology level. If you are able to design, develop, then you have a great potential. Okay, otherwise it's a simple automation. No, it's a laborious job. Even if you see a mobile manufacturing company, actually engineers are also not required. It's a skilled labor. Same thing in happens semiconductor. If it is a manufacturing, it is a skilled labor. But we do not want here to be a labor. We are supposed to be designers, developers. So that kind of expectations are there from the industry. They know what Indians are. That's the reason why these companies are investing. And that's called Industry 4.0, where people talk about smartness and Internet of Things. And these are all the disruptions happens because if you invest in one area, other area will suffer, and so on. So finally, technology is a choice, right? It is a choice. Which technology choose, what application to choose is a choice. Now you need to look at being a student, being a designer, being a manufacturer, which technology, even your final year project, which technology you want to choose for design and development. Okay, so actually I'm supposed to talk on this slide, but I will take only 1 minute. Project, product, research. These are the opportunities. Unfortunately, what is happening? We only focused for 30 plus years only in projects. Today, projects doesn't have any value. We are doing projects only for getting a marks. Once the marks are given, we forget about the project. That's all. We dump it, whatever we have done. But if you see the market, what market is looking for is not for the project. What is project? Project means you are actually projects are good. Earlier generation projects were good because project means what? Maximum learning happens. You learn some tools and technology in projects. Unfortunately, last 10 years, project means copying the things. There are popular websites are there, popular shops are there. You go there, you buy the things, you see those websites, you copy the things like Raspberry Pi boards, Arduino boards, Eagle boards, Beagle boards. You plug the things will work, you demonstrate, project is done. That means you have learned how to copy the things. That's why today projects doesn't have any value. I'm telling at national level. You understand? I speak these things at every national stage. Raspberry Pi, Eagle, Beagle boards are not meant for engineering students. They are meant for school kids up to 7th standard, not even after 7th standard. In Government of India, they have given these boards as a tinkering, adult tinkering labs to schools. So do not bring these boards to engineering education. If you bring these things to engineering education, that means you are a school kid. And if you go to industry, they still see you as a kid. You understand? If you go to any investor to start a business, and if you say, I have designed my product by using a Arduino board, Eagle board, they see you as a kid, 10th standard or 7th standard kid. Do you understand? Design means the entire circuit, layout, PCB, everything is a choice. I've shown you 10 plus companies where they have products. Choose those components, design your own system. The system has to be designed by you. Then it is called patentable work. Copying the things are not patentable. It's already published work. If you have taken something from the website, you cannot patent it because it's already published. Patentable means you have a copyright in your hand. If you have a copyright in hand, one day some country, some company will definitely come to your doorstep say that I want to buy your copyright. There will be investment automatically will come. So that's why I said stop doing projects, because project means you understand, your generation understand copying the things. So forget about, so don't do projects. When you are doing anything, do a product. Now start thinking what is product. Product means patentable thing. So what is patentable? Where which is not existing. Some delta T contribution is there from your side. What is that? You have to figure out. Okay, finally research. Research outcome. Research outcome means, right? That is not existing, not even there, right? You have contributed. So delta T knowledge you have added to the existing knowledge. Today the knowledge is here, you have added a delta T. We don't expect at engineering level, but since you aim to go for PG education, some of you are aiming, at least at SPIT, 20% of the students aim for post graduation, then we expect in your final year at least think of doing a research oriented project. Then you are likely to get a good admission in good world class universities. So how to get a admission in world class university unless you have a research attitude? So it's not a project, it's not a product. So think of what is research. So if you try to add something in your profile, I have done a little bit of research kind of a project in my thing, then there is a possibility that you will get some stipend, some scholarship, your fees may be waived off, you will get some TA, RA, or a good admission in world class university. That is what you have to think of. So these are some outputs or outcomes as a student level, I would say. So think of it. So please scan this. You are supposed to give some feedback uh, and upload on the website. The remote center, Phenolics Institute, you take your own feedback at your level. This is for our center, SPIT center.
Yes, sir. Sir, thank you very much for your valuable insights in the field of semiconductor industry, the manufacturing and financial aspects. On behalf of Phenolics Academy of Management and Technology, I would like to thank for your valuable expertise in this domain. This is the first time we are having this association, but we would like to continue this association in future also. So thank you once again.
Sure,
We will
madam.
end the session here. Have a
Yeah,
good day,
please.
sir.
Yeah. Thank you,
Thank
madam.
you.
Thank you very much. All right. Have you, all of you, attendance? This is as good as your attendance. All of you scan it because your email will be captured there. And select the center of Mumbai center. We belong to Mumbai RO, regional office Mumbai. That Google drop down, select Mumbai center. Okay, so after this, we have a prime minister's. This thing is there. I will broadcast that. Once the session is over, students of uh, after the session, uh, A division after the prime minister's speech, A division can go back. B division be here. My session, my lecture is there. All of you have done the scanning. Anybody left? You will be absent otherwise. भूमि पूजन करेंगे। ये विश्व में रिकॉर्ड है, ये संभव होता है लीडर देश में आपने राज्य और केंद्र सरकार दोनों ने अपनी पूरी ताकत लगा दी। आज हमारे साथ यंग और एनर्जेटिक 30 लाख से ज्यादा जो साथी वर्चुअली जुड़े हैं। आपसे मैं कहूंगा साथियों, नौजवान साथियों, आपके भविष्य का निर्माण करने वाली ये इंडस्ट्री है। आपके फ्यूचर को सिर्फ करने वाला ये फैसला है, और ये फैसला केवल और केवल मोदी जी ले सकते हैं। ये जब आप अपना निर्णय लें आने वाले कुछ दिनों में, तो याद रखना, आपके भविष्य का ध्यान केवल और केवल मोदी जी रख सकते हैं। इस बात को आप अपने मन में रखना जब आने वाले कुछ दिनों में आप अपना देश का फैसला लेंगे। इस ऐतिहासिक समारोह में माननीय प्रधानमंत्री जी, आपका और सभी साथियों का हार्दिक अभिनंदन। जय हिंद, भारत माता की जय।
धन्यवाद महोदय। मैं आज माननीय प्रधानमंत्री महोदय के शुभ कमलों द्वारा होने वाला ये शिलान्यास आर्थिक एवं प्रौद्योगिकी परिदृश्य में क्रांतिकारी बदलाव लाएगा और देश के सुनहरे भविष्य का निर्माण करेगा। अब मैं चेयरमैन सीजी पावर एंड इंडस्ट्रियल सॉल्यूशंस लिमिटेड श्री विलायन सुबैया से संबोधन का अनुरोध करती हूँ। श्री विलायन सुबैया।
Honorable Prime Minister Narendra Modi ji, Honorable Chief Ministers of Gujarat and Assam, Honorable Ministers Vaishnav ji and Chandrasekhar ji, colleagues, our partners and guests. Namaskar. 75 years ago, my grandfather manufactured India's first bicycle. That was what the country needed at that time. Times have changed. Semiconductors are the new bicycle. These are the very basis of a modern manufacturing economy. They are critical to India's Atmanirbharta. Today, it is not just about laying the foundation stones of Tata steel plants and our plants, but the very foundation of India's emergence in the modern economy and an announcement of India's arrival on the global semiconductor stage. Why did we have to wait until now for this moment? What Bharat is now witnessing is as revolutionary as independence itself. We are seeing an awakening and a resurgence that India has never ever seen before. This government's ability to foresee what Bharat needs to be a world leader is absolutely unprecedented. Government and industry are collaborating effectively, leveraging each other. मैंने सोचा अगर चिप्स का है इंतजार तो सीजी है तैयार। Until now, Indians have helped other nations strengthen their leadership position in the world order. Brain drain. When I graduated from IIT, 140 students out of my class of 290 left for the US. This will no longer be the case. From now on, we will design for Bharat. We will make for Bharat. We will build Bharat. We are fortunate to have a very strong Japanese partner, Renesas. We asked Renesas who will be leading the initiative from their side. And they said Viresh Patel, who is here with us. मैंने बोला ये वीरेश पटेल तो जापानीज थोड़ा है, but this is the nature of the world today. Country or company, Indians are in leading roles. That's something we want to be proud of. We are excited to set up this initiative in Gujarat. We come from Tamil Nadu. In Tamil Nadu, we have 79,000 temples. Gujarat has 50,000. It seems that both Tamils and Gujaratis are fond of going to temples. That's basically because we all understand that there's something much bigger than ourselves. For me as well, yoga and meditation is important. In India, we understand that sadhana and bhakti actually help us become better leaders, help increase our intensity, our energy, our focus. So together, in the presence of Adi Yogi, we will create an intensely powerful semiconductor ecosystem that is built on the foundation of spirituality. I've written a few lines in lighter vein. हम सब हैं एक परिवार, हमारा डोसा आपकी चाट, देश का विकास सेमीकंडक्टर्स के साथ, तेज रफ्तार सीजी के हाथ, to rising India, जय हिंद, प्रणाम.
It's a strong line in the sky of growth and development of Bharat. और अब समय है चेयरमैन टाटा ग्रुप श्री नटराजन चंद्रशेखर द्वारा संबोधन का. महोदय, आपसे विनती है कृपा करके अपने विचार प्रस्तुत करें. श्री नटराजन चंद्रशेखरन.
Honorable Prime Minister Shri Narendra Modi ji, thank you for gracing us with your presence on this historic occasion. This event is possible because of your enduring vision to bring the semiconductor industry to the shores of our country. Thank you, sir. बहुत बहुत धन्यवाद. I am also privileged to welcome Honorable Chief Minister Shri Bhupendra Bhai Patel ji, Honorable Minister Shri Ashwini Vaishnav ji, Honorable Chief Minister Shri Himanta Biswa Sharma ji, and Honorable Minister Shri Rajiv Chandrasekhar ji to this event. Dignitaries from Government of India, Ministry of Electronics and Information Technology, India Semiconductor Mission, governments of both Gujarat and Assam, distinguished guests, ladies and gentlemen, and members of the media. I am thankful to all of you for your presence here in Dholera and Jagi Road, Assam, for the foundation stone laying ceremony of India's first semiconductor fab and the first indigenous semiconductor assembly and test facility. Today is indeed a very, very special day for India and for the Tata Group, with the foundation stone being laid simultaneously for our projects in Dholera and Jagi Road, one in the east and another in the west, 2,500 kilometers apart. These semiconductor manufacturing hubs will have a very lasting impact on the entire nation. The ecosystem from across the globe will mobilize to have India as their preferred semiconductor destination. For our fab, we are very excited to partner with Taiwan's Orchid Semiconductor Manufacturing Corporation. The executives from PSMC are